Okay, so looking at solving properties of systems. We have three different scenarios that we can have. All right, so three different scenarios. Scenario one, this is the normal case. So normally when you have your system, what can happen is you get one answer, okay? So in the normal case, you have one solution. That's it. Whoops, I wrote that in the wrong spot. You'll have one solution. And the normal case is when you basically, you have two different lines. If you want to close that door, feel free to. Okay, so two different lines. Okay, what you're going to do is you basically have two different lines because you have different slopes. So you can turn both equations into ax plus by equals c, or plus c, wherever you want it to be. But your slope comes from your a and b. We have seen that repeatedly. It comes from the numbers in front of x and the numbers in front of y. All you have to see is these are different. Okay, so these are different numbers, whether that's positive or negative or whatever. But if you have different numbers in that location, it doesn't matter what c is. What you're going to do is you're going to have one solution. Okay, so if you have different numbers, you will have one solution and only one solution. The lines will cross only once. C does not matter. So we don't even have to care about our intercept, which is our C value. Well, C divided by B. Okay, now the other thing you could do is you could turn it into y equals mx plus b. And then you could compare slopes. Okay, this would have to be different slopes. So as long as you have different slopes, C don't matter. Your lines will cross once and only once. The next situation, and you've seen this one now before in your graph, this situation is when you have parallel lines. And how many times do those lines cross? Well, they don't cross. So this one would be no solution. Okay. Or you can use the null set, right? Null set means no solution. Or the other thing you can write down is zero solutions. Don't write down zero because the zero is not the correct answer. Zero solutions is the answer. If you're writing down the word zero, then you're indicating that that's the answer. So having the word solutions is important, okay? So if you have parallel lines, what you're going to see is that you have the same slope. Okay, but different intercepts. So in our example here, we have an intercept of -1 and an intercept of +2. The slopes are the same for each line. The slopes are 1/2. Okay, so here m would equal 1/2, but you have two different equations for those lines. All right, they've just split up. Any questions about that? So if you have your equation in ax plus by equals c, what you'll notice with the two equations that these will be the same, but this one has to be different. So when you're looking at equations, that's what you're looking for. Okay, so both equations will be the same, but your c value will be different. How many lines do you guys see here down below? Wrong, there's two. Where's the second line? Exactly. So here you have what we call coincident lines. Let me write it sideways here. Coincidental. Here we go. Coincidental lines. Okay. That's just the fancy math speak for the same lines. They're on top of each other. How many solutions would there be? How many times do those lines cross? An infinite amount, right? So there are infinite solutions. Okay. Or you could write many solutions. Now, don't write infinity, okay? And that's right. So you don't want to say this. That would be incorrect because that's indicating that that's an answer. It's not. The proper way to write it would be infinite solutions. You got to have the word solutions there. Okay. So you have to have the same slope and the same intercept in order to be the same line. So same, same, same. In order to be the same, you have to be the same. Now, I'm not going to go and give you an easy question. So A and B would be the same, and your C value would also be the same. What we would do would be something like this. One line would be 2x plus 3y equals 5, and the next line would be something like 6x plus 9y equals 15, right? So if you have that, they look different, and I can even make it even harder by using fractions, but they're the exact same line. One was just multiplied by 3, okay? So you got to be careful of that. So let's practice solving some of these questions. Your questions are going to be like this. How many solutions are there? Or determine the number of solutions to the system. Okay, so if you're looking at these two here, if you tried to solve this, you would end up getting 0 equals 0. So if you're doing your work and also you get something weird like that, well, you better go and look again. So let's try and eliminate these. Let's make, what do you want the same to be? X's or Y's? Hayden, you choose. Y. Okay, so what's our LCM for the Y values of 6 and 4? 24 or 12. So let's get ourselves into 12Y. What do we have to multiply this one by? 3. 2, right? Multiply by 3, so we want 12Y. So you can get 18x minus 12y equals 24. And what are we going to multiply the bottom one by? 2. And so we get 18x minus 12y equals 24. So what do you notice? Exactly the same. So you would say same line because same slope, same intercept. Therefore, okay, you can write the word therefore or use the shorthand symbol. Therefore, infinite solutions. Okay, so same slope, same intercept, infinite solutions. The bare minimum, you got to talk about the slope and the intercept. That's the bare minimum for each question. Any questions with this? It's a little bit new for you guys, right? This is kind of like a new side of math. A little bit of less calculations, the more interpretations. Wow, that's a good line there. Okay, next, example number 2, determine the number of solutions. So, what do we want to get the same, the x's or the y's? You choose. Haley, sorry. Sounds good. So what do you multiply the top one by? Yeah. Awesome. Good job. Okay, get the top one the same. Go for it. And what do you multiply the bottom one by? 2. Okay, so multiply the bottom one by 2. So what do you guys notice? Yeah, what's the same? Yeah, A and B? What about C? So what does that mean when A and B are the same? It means the same slope. What does it mean when C is different? What's different? Different intercepts. Correct. Same slope, different intercepts. So that means you have parallel lines. So you will have 0 solutions. Now I purposely worded my answers slightly different so that you can see you can word things different. But what do I have mentioned? The slope and the intercept, and then what case it is. Okay, back here I have the case mentioned as well, same line. But you got to tell me, what do you notice about the slope? What do you notice about the intercepts? And then, of course, the bottom, what does it mean? Like, how many solutions are there? So you have to have reasons for your answers. Okay. All right, let's do the next one. Let's eliminate our x's this time. Let's eliminate our x's just to switch it up. So what would be your LCM for 9 and 6? 18. Okay, so you want to get to 18x, multiply the top one by 3. So what do you notice? Almost the same, but what's different? Yeah, the y number, the negative. So what change? Like, what makes that difference between the lines then? They will cross, but why? No, you got to talk to me about the slope and the intercept. Are the intercepts the same? They're actually not because of the negative 12 part, but the 24 is the same. But what's different for sure? Slope. So you got to notice that, look there first, and notice it first. Different slope. So what does that mean? Well, it means you'd have different lines. So, ... how many solutions? 1 solution. 1's not the solution, but there is 1 solution which you could then solve. Okay. Now, if you're solving example 3, you'd actually get your answers quite easily. example number 2, you get something really weird, right? You get 0 equals 0, and that would tell you, hey, I better go see what's going on here. For example number 2, you're going to get weird stuff too. If you tried to solve example number 2, you would get something like this. You would get like a number, you would get something like 36 equals 0 or 0 equals 36. If you get something weird like that, that's not a true statement, then you got parallel lines. You got to go back and have a look and tell me that you have parallel lines, okay, and that you have many solutions. So if you're getting some weird stuff when you're solving, you have one of those situations. Now, on the whole test, do you think I'm going to put like 5 or 6 or 7 of these on there? No, I'm probably going to have one. In your solving where I'm getting you to solve, there's probably one situation, maybe, where you would have to then go and do more work. You'll have lots of these examples, right? Like you'll have examples like numbers 1, 2, and 3. You'll have lots of those. In fact, you have a whole page of like 5 questions on telling me what kind of solutions you have. But in the solving section, you're probably only going to get one, okay? If one. So I do have to make the test a bit shorter. Does that make sense? I'm just, only reason I'm warning you this is people make an algebra mistake and then they start saying, oh, everything's no solutions or many solutions, parallel lines, all this. It's not a lot of them, okay? All right. Just to wrap up then, here's a tougher one. Okay, so if you have this linear equation, what could you do to make it infinite many solutions? Infinitely many solutions. So if you have infinite many solutions, that means you have what? Yeah, same line, so you're going to have the same slope and same intercept. So if you took this equation, just multiplied it to get rid of your fractions, what number would you multiply by to get rid of your fractions? So multiply it by 6. So if you went and multiplied it by 6, you would get something like 2x plus 3y equals 48. So all you did is you times it by 6, and you have the exact same equation. So you get infinitely many solutions. Okay. What about no solutions? What situation gives you no solutions? Yeah, you'd have parallel lines, so you'd have same slope, but you'd have different intercept. So the only way to keep the slope the same is to have this, 1/3 x plus 1/2 y. That stays the same, but then this would have to be, your c value would have to be different. Pick a number, any number. Gurman. 3, sounds good. Now you have parallel lines. Okay, the only stipulation is that this can not be 8. Okay. Could you make a harder equation and get rid of your fractions? You totally could. You could totally get rid of your fractions. You just doing more work, right? You're just doing more work. All right. And what about one solution? Which situation is there where you only have one solution? Yeah, the normal case, right? You just need different lines. So all you need here is a different slope. That's it. Just a different slope, okay? So you could just make one change, that would be fine. So one change or many changes, your choice. But we're going to keep things the same. So 1/3 x plus y equals 8, okay? And let's say this is like a 4, right? You only need to have one change and you'll have a different slope. Okay, this could, anything else could be really anything. Right, as long as you're not getting the same line or parallel lines. Sound good, Trevor? Any questions? These ones are going to be a little bit more challenging for you because they are from the textbook. Nope, this is not. Ooh, shoot. Am I really here? Darn it. I don't want it to be here. Okay. So, today's work is from the textbook, page 448. Those are some challenging ones. I think for us, let's just stick with the basics. And then once you're done the basics, so you've done all of the lesson work, you can start the review, okay? And the review will be review 1. It's at the back. Any questions? Okay, work hard. You got an hour. Work hard. Test is tomorrow. Practice up.
Forgot about my kidney.